Hello friends, today I am going to delineate the topic binary number system. Binary number system is the most important number system to understand because computer only understand binary language, and moreover all the manipulations are done by processor in binary language only. And now let's have a look over the term binary. The word binary has derived from the Latin word bi, which means two. For example, bidirectional, bicycle, bilingual. Bidirectional means movement can be done in both the direction. Likewise, telephonic communication is termed as bidirectional communication. Bilingual means one who can speak two languages fluently. And now let's have a look over the domain set of binary number system. First, again, what is domain set? A set of unique elements is termed as domain set. What is the domain set of binary number system? Domain set of binary number system includes just 0 and 1, two different symbols. Because it has two different symbols, so the radix or base of the binary number system would be 2. These two different symbols are termed as binary bits or simply bits in the binary number system, and they also have one additional meaning here, which means where 0 means off state and 1 means on state. Now let's have a look on some examples of binary numbers. Now first I am going to discuss what are the protocols to write binary number. We can write the binary number by using the domain set of binary number system. That is, we can use only 0 and 1 bits. Now this is a valid binary number. Why this is a valid binary number? Because all the bits of this number belong to the domain set of binary number system. This is also a valid binary number, but this number is a fractional binary number. And why this is a valid fractional binary number? Because all the bits before the decimal point and after the decimal point belong to the domain set of binary number system. And one more example I have written here, and this number is not a valid binary number. Why this number is not a valid binary number? Because this digit 5 doesn't belong to the domain set of binary number system. So it's not a valid binary number. And one more thing, always employ base 2 to make it as a binary number, and also put base 2 to make it as a fractional binary number. We can't employ base 2 here because it's not a valid binary number. Now let's have a look on the definition of binary number system. A number system in which a number can be expressed in base 2. A number can be expressed in base 2. See here, a number can be expressed in base 2 is termed as binary number system. Now all these are the other names of binary number system. Why binary number system is termed as base 2 number system? Because the radix of binary number system is 2, so binary number system is also termed as base 2 number system. And why binary number is termed as positional, weighted and place value number system? For this again all of you will have to watch the video till the end, and you will get to know about all the answer of your queries. Alright. Likewise, in my previous tutorial of decimal number system, I have explained of getting weight positions in decimal number system. I am here going to explain how can we get the base positions in binary number system. We all know that radix of the binary number system is 2 and unit place will remain 1. And now let's understand the process. Unit place is 1. Now the question is, how can we get the next weight position in binary number system? And the process would remain same as I explained in the decimal number system. Previous weight position value multiply by radix of the number system, that is 2, and the value would be 2. Writing this number again, and for the next weight position the value would be previous weight value multiplied by radix of the number system, and the value would be 4. And for the next weight position, previous weight position value multiplied by radix of the number system, and the value would be 8. And we follow the process so on. And this is how we have got the weight positions successive to the left of the decimal point. Now again the question is, how can we get the weight positions successive to the right of the decimal point? And the process will remain same as I explained here. Just replace the multiply operation by the divide operation. Let's understand how can we get the next weight position here. Previous weight position value divided by radix of the number system, that is 2, and value would be 1 by 2. For the next weight position, previous weight value divided by 2. Solve this. 1 by 2 divide by 2. 1 by 2 multiply 1 by 2, and the value would be 1 by 4. Write it here, 1 by 4. And what would be the next weight position? Previous weight value divided by 2, and you will get 1 by 8, and continue the process so on. This is how we have got the weight positions successive to the left of the decimal point, and this is how we have got weight positions successive to the right of the decimal point. So we can write this scenario in another form as well. Let's have a look over the other scenario of weight positions of binary number system. The weight positions in binary number system can also be written in this form, and both the scenarios are said to be equivalent. And again, try to be the habitual of this form, as you can get the same method in the standard books as well. And what deduction we have got here? Each place is a power of 2. Power of 2. See here, each place is a power of 2. So binary number system is also termed as base 2 number system. Now taking example of binary number. Binary number is 1001, and put base 2 here to make it as a binary number. Now place the bits of this binary number under its corresponding weight position. What are the weight positions? 1, 2, 4 and 8. And what are the binary bits of the number? 1001. Now multiply the binary bits to its corresponding weight position, that is 8, 0, 0 and 1. And the final answer would be the sum of values of all the positions, and you will get 9 here. And now let's concentrate here. This 9 can't be a binary number. Why this can't be a binary number? Because the domain set of binary number system just includes 2 bits, that is 0 and 1, and this 9 doesn't belongs to the domain set of binary number, so it can't be a binary number. This is a decimal number, so employ base 10 to this number. And again, try to be the habitual of using this method, as you can get this method in the books as well. So what I have done here is multiply this binary bit to its corresponding weight position, that is 1 multiplied by 2 raised to the power 0. Multiply this bit by its corresponding weight position, that is 2 raised to the power 1, 2 raised to the power 2, and multiply this one by 2 raised to the power 3. When you solve this equation, you will get answer 9, and again employ base 10 here. So what deduction we have got here is that whenever we write the bits of the decimal, the bits of the binary number under its corresponding weight position, and solve the equation, then you will get the resultant number in decimal number system. Okay, I hope guys you have got my point clearly. Now I am explaining why binary number system is called as positional weighted or place value number system. See here, what we are doing here, we are writing each binary bit corresponding to its weight, or you can say it's corresponding under its corresponding position. So binary number system is also termed as positional weighted or place value number system. I hope you guys have got my point clearly, and thanks for watching this tutorial, and expecting you in my next tutorial as well. And hit like and subscribe if you genuinely like the content. Thank you.